Last example here in the mole conversions. How many atoms of oxygen are in 32.5 grams of potassium permanganate? Okay, we've got to consider what is potassium permanganate, and is atom the representative particle? Well, we know that right off the bat, because the sample that we have a measurement on is potassium permanganate, but it's asking about oxygen, right? So those are two different things. Oxygen is an element that will help to make up potassium permanganate. So we know already, just right off the bat, we're going to have to go one extra step, because oxygen is not what we have data on. We have data on the whole compound, and so we have one extra step to figure out oxygen. So let's try our number, our unit, and our chemical. And boy, that is a long one to write out, so I definitely want the formula. Potassium is in the first column of the periodic table, so it has a charge of +1. Permanganate is one of our polyatomic ions, and it has a charge of -1. So +1 and -1 cancel out, and it's just KMnO4. So 32.5 grams of KMnO4 to start, and we'll place all of that over 1. And then we're going to multiply by our conversion factor, which is going to be two things from down here on the bottom row, two of these things from our mole triangle. Grams of potassium permanganate is the first thing we're going to deal with. We see grams tucked in with the molar mass. So that means I need to actually calculate the molar mass. I forgot to do that right at the beginning. So let's go ahead and calculate that. Since the formula is KMnO4, there's 1 potassium, and potassium in my periodic table is 39.09. And there's 1 manganese, and manganese is 54.94. And there are 4 oxygens, and oxygen is 16.00. So if I run that through my calculator, I've got 1 times 39.09, or just 39.09, plus 1 times 54.94, or just 54.94, and then plus 4 times 16, and that's going to give me 158.03 grams. Remember, we're using the convention, we're going to round molar masses from the table to 2 decimal places. So now that I have that molar mass, I can plug it into the bottom of our conversion. So I've got molar mass in grams in the top. I need one of these other things from the very bottom row to go in the top of my conversion factor. Since we're looking for atoms, we're going to go through formula units, right? Formula units first and then atoms, since we have to do that extra step. So my next step is going to be 6.02 times 10 to the 23rd formula units of potassium permanganate. And then one more step to say that every 1 formula unit of potassium permanganate has 4 atoms of oxygen. And now I just need to run that through my calculator. Let's see. Oops. Yeah, it's okay, Kitty. You can get down. Let me finish the video. All right, so we've got 32.5 times 6.02 EE23 divided by 158.03 times 4. And that's going to give me 4.95 times 10 to the 23rd atoms of oxygen, I hope. Let's make sure everything cancels out. Grams of potassium permanganate, cancel grams of potassium permanganate. formula units of potassium permanganate cancel out formula units of potassium permanganate. So yeah, all that looks good. Phew, last example. So I hope these mole conversions make some sense to you. If they don't, please go back and try again. See if you can look at the problem and try to work it yourself, and then compare what you did to what I did, and see if you can make those two things, two approaches, come to the same conclusion.